Let's look at some word problems dealing with conversions. Sally's child weighed 9 pounds, 8 ounces when he was born. At his first doctor's appointment, he weighed 11 kilograms. How much weight in kilograms did the child gain? So if I'm looking at what's going on here, I'm looking for how much weight the child gained. So I'm looking for a change or a difference. They're telling me that the child originally, started out at this 9 pounds, 8 ounces, and then later on weighed 11 kilograms. So if I'm trying to figure out a change or a difference, I need to subtract. But when I need to subtract, I need them to be in the same units. So I'm going to look at what units they want my answer in, and that's what I'm going to convert everything to and work with. So they're just asking me how much weight in kilograms did the child gain. So that means I want to get everything in kilograms first. So my first step is going to be to get all the units into kilograms. So that 11 kilograms, that later measurement, is already there. So the thing that I really need to convert is the 9 pounds, 8 ounces. So the first thing within this step that I'm going to do is I'm going to convert the ounces to pounds. So I know if I have 8 ounces, I'm in that standard system, and there's 16 ounces in 1 pound, I can do my dimensional analysis to get those ounces to cancel out. I'll end up with 8 over 16 pounds, which is just 0.5 pounds. Then I can add those 9 pounds to it. So the original weight, that 9 pounds, plus that half a pound, tells me that this child weighed 9.5 or 9.5 pounds. But I don't want the answer in pounds. I want this number in kilograms. So I have the 9.5 pounds. It's involving that English system or standard system, so I'm going to use dimensional analysis. I know I'm going to want pounds to cancel out and my kilograms to be left. So I'm going to use this conversion that has my 1 pound is about 0.45 kilograms to avoid having to deal with that division of messy numbers, right? When I multiply straight across, I have 9.5 times 0.45. That gives me 4.275 over 1, or 4.275 kilograms. Now I'm not at my final answer and they didn't tell me where to round, so I'm just going to leave this number. So this isn't our answer, but it's the baby's weight when he was born. So now I'm going to do the second step. I'm going to actually figure out what they asked me. How much weight did the child gain? So we said that was a difference or a change, so I need to do the subtraction. So I'm going to take that 11 kilograms and subtract out that 4.275 kilograms. When I do that subtraction, 11 minus 4.275, that gives me 6.725 kilograms. So that's how much weight this child gained between birth and the doctor's appointment. Let's look at another example. They're asking us to find the area of a rectangle in meters squared with a length of 13 feet and a width of 9 meters. So if I picture what's going on, right, I have 13 feet by 9 meters. So I have different units again. They're telling me to find the area, so I know area is length times width, and that I want that answer in meters squared. So the first step that I'm going to do, just like before, is get all the same units. So I'm going to get the feet into meters. Now, we have a few conversions for that on our conversion sheet. We know that we can use either 1 foot equals 0.30 meters, or we could use that 1 meter, or I'm sorry, is about 3.28 feet. So if I set this up, I've got the 13 feet. I'm using the standard system, so I need to use dimensional analysis. I want the feet to cancel out, and I want to have meters up here. I want to try to get the 1 in the denominator to make my life a little easier, so I'm only doing multiplication, not division. My feet will cancel out, and I'm using this conversion then, that 1 foot is 0.30 meters. When I multiply 13 times 0.3 or 0.30, I'm going to end up with 3.9 over 1, or just 3.9 meters. My second step then is going to be to actually find the area. So instead of this 13 feet, I'm thinking of 3.9 meters. My area is the length times the width. So it's going to be that 3.9 meters times 9 meters. I'll multiply those numbers, so 3.9 times 9 gives me 35.1, and then I know meters times meters gives me square meters. Let's look at another example. It says find the volume of a cylinder in centimeters cubed that has a radius of 37 centimeters and a height of 2 meters. So they're telling me I have a cylinder. They're telling me that I have a radius, so from the center to one edge, of 37 centimeters and a height of 2 meters. They're asking me to find the volume of the cylinder, so I know the volume is the area of the base, so the area of the circle, pi r squared, times the height. And they're telling me that I need my answer in centimeters cubed. So just like before, my first step is going to be to get all the units into centimeters. So in this case, the thing I need to fix is this 2 meters. Now here, I'm using the metric system. I need to go from meters to centimeters, so I can use that decimal bumping. So I have King Henry died Monday drinking chocolate milk. I'm dealing with length, so I want meters with an M after everything. I'm starting from meters, and I want to end at centimeters. So I'm going 2 spaces to the right. So that 2 meters has a decimal point at the end of the 2. When I bump it 2 spaces to the right, I find that 2 meters is really 200 centimeters. So I'm not thinking 2 meters anymore. I'm thinking 200 centimeters. Now I can do that second step and actually find the volume. So I'm going to use that formula, volume equals pi r squared times h, and I'm going to use that approximation for pi, that 3.14. So if I do this, volume equals 3.14 times the radius, 37 squared, or actually let me include my units in there, 37 centimeters squared, times the height, the 200 centimeters. So when I plug this in my calculator, I have 3.14 times 37 squared times 200. When we do that, we get 859,732. And then for volume, it's always our units cubed, so centimeters cubed. Let's look at one more word problem. It says if a baseball diamond measures 25 meters on one side and a person hits 2 home runs, how many kilometers will they run? So this is a problem that's similar to the homework, and I like to review it because it involves some background knowledge with baseball. If you're not a baseball fan, you might not know what all of this means. So in baseball, we have a diamond where this is home plate, this is first base, this is second base, this is third base. So in this case, they're telling us that it measures 25 meters on one side. Because it's a diamond, it measures 25 meters on every side then. And they're telling us that the person hits 2 home runs. So if they just went from home plate to first base, that would be a single. They went from all the way to second base, that would be a double. To third base is a triple. And then back to home plate is the home run. So they're telling us that this person hits 2 home runs. So if we think about 1 home run, they're going that 25 meters 4 times. So they're running 100 meters for each home run. But they're hitting 2 home runs, so I'm going to take that 100 meters and multiply it by 2. And find that it's 200 meters run for 2 home runs. But they didn't ask us how many meters will they run. The question they asked is how many kilometers will they run. So I'm going to take this 200 meters and I'm going to convert it to kilometers. These are both in the metric system, so I'm going to use that decimal bumping in that acronym. So I have King Henry died Monday drinking chocolate milk. It's all meters, so I want an M after everything. And I'm starting at meters, and I want to go to kilometers. 1, 2, 3 spaces left. So I'm going to take that 200 meters, my decimal points at the end. I'm going to bump it 1, 2, 3 spaces left. And I'll find that I have 0.2 or 0.200 kilometers.